Hello, my name is Ethan Guerra, and this is my reverse engineering flashlight model project. First, we are given a prompt. I work for a failing flashlight company, and our competitors are winning, so we must dissect their product and make a better version of their flashlight at a cheaper price given customer complaints and a model of invention. We're given 3 restrictions. First, we cannot add $10 in extensions, it must still be a flashlight when it's finished, and it must agree to the customer needs. This is the original flashlight, solar panel, lens, button, crank, etc. This is a technical drawing of the flashlight. You can still see the crank, the lens, but you can also see what's inside from the gears to the battery, etc. This is my prediction sketch. This is what I thought was inside before I knew what was inside. As you can see, there's multiple differences ranging from where the wires are put. You can see the battery is much bigger and the crank is, and the piston is powered much differently. In my idea, I thought mechanical force is cranked into the system and turns into electricity when the piston pushes the main mechanism back and forth. As you can see here, it's pushed back and forth when it spins, and right here in the main prediction sketch. These are all the individual dissected parts, ranging from housing screws all the way to circuit boards, bodies in there. All 29 parts are listed right there, on which axis, what tool needed to extract them, and their material. These are all the parts drawn from body, solar panel, screws, circuit board, etc. This is a black box model. It shows you where the energy is being put throughout the system. You put the mechanical energy from your arm into the crank, and it is then cranked into the gears, which are then spun and put into the magnet coil. The magnet coil turns the mechanical energy into electrical energy, and then it shoves it through the wires and pushed into the bulb. The bulb turns the electrical energy into light energy, and then it shoves the light through the lens and then shown at the object that the flashlight is pointed at. These are all the tests we've taken. We took a brightness test, how much force it takes to spin the crank, and how loud the crank is. We measured at 4 different distances, 1 inch all the way to 36 inches, to measure how many lumens would reach the end of the wall, Then we measured how many pounds it would take to spin the crank and how loud the crank could go. And we tried each of those 3 times. 5 features of the flashlight could be improved, what we saw. We thought the amount of light entering the solar panel could be improved. With the amount of force needed to spin the crank, we thought we could lessen the amount of light shined in a specific area. We wanted to make it easier to hold, and the amount of noise made could easily be decreased in our minds. So we created multiple ideas. First, we created the head strap for ease of holding. We made a convex lens so more light could be shown in a specific area so it can be brighter. We needed gear grease to make the gears less noisy. That was the main problem. And we have to cover the LEDs to adjust the amount of light just in case the customer wants to shine less brighter in their flashlight. An option to lengthen the crank so it is easier to spin was an idea we created. We wanted to use more energy from the battery and push it into the LEDs so they can shine brighter. And to counteract the amount of energy we are taking from the battery, we wanted a bigger battery so it can last longer. 3 ideas were constructed. We created the extendo crank, the convex lens, and the adjustable LED cover, as sketched below. First, this is the extendo crank. As you can see, it opens like a flip phone, and you can choose whether you want to spin the short one or the long one. You can choose whatever you want. The shape is shown right here. This is the short one, the long one. There's a hole at here, so the pole is still there when it is extended, but you can use the long one. This is the convex lens, showing the focal point, explaining convex lens. Unlike the concave lens, the convex lens focuses light to a specific point. This causes light to shine brighter in a specific area because more light is being focused on that point. This is the LED cover. With the LED cover, the customer can make a choice on how much light is being emitted from the flashlight by sliding a piece of opaque plastic. This piece of opaque plastic acts as a curtain to cover the specific amount of light without measurements. As you can see, it can be pushed back and forth on a lateral axis, and it cannot escape due to the plastic holsters that are idealized in these two drawings. This is the cover piece itself. This is how it is latched in. Thank you for listening to my presentation. I'm Ethan Guerra again, and yeah, thank you.